Hey there, welcome to Solve My Math Homework. You know, we're the channel that solves the math problems our subscribers send in. And so this was clearly taken a picture here from a study guide for a calculus final. And it asks you to draw the graph of a function given parameters that have to do with the limit of that function, okay? And the limit they give you is very unique. It says that the limit as x approaches 2 of the function, and let's make sure we know how to read this. This says the limit as x approaches 2 of the function, because f of x is just the function, equals 1 when x is greater than 2. Another way you may have seen that written is the limit as x approaches 2 from the right, because remember, larger numbers than 2 are over here on the right. So that's called a right-handed limit, okay? And then it says, but the limit as x approaches 2, so we're still approaching 2, is 2 when we are approaching it for values less than or equal to 2. So we could say the limit as x approaches 2 from the left. All right, so let's talk about something about limits. The limit is the intended height of a function. So if I'm giving you a function graphically and it looks like this, okay, and let's say this right here is my value. I can't draw dots with these, it's actually quite annoying. Let's say this is A and this output here is B. Then the limit as x approaches this number A is equal to B. That's the intended height of the function. However, if I change it just a little bit and I make something that looks like this, the big old hole in my graph, and then I connect the rest of it, okay? So let's pretend this actually hits that circle. So this means there's a hole in my graph. But that's still the intended height of the function. So the limit as x approaches a is still b. The difference here is that f of a, the value of the function at a, is undefined because there's a big old hole in the graph. There's no value there. Okay? Another way I could write this, I can give you another example of maybe where the limit exists but there's no value at the function. Let's put numbers in too because it's always easier when there's actual numbers. So let's call that 3. Wow, that is the worst 3 I've ever seen in my life. Okay, let's call it 4. All right, and let's draw something similar. So there's this, and let's say it's coming from this direction and going like that. Okay. All right, and then let's add another little hiccup to the system. Let's put this down here. That's a dot. Okay. So what have I just done there? All right, well, I can say now the limit of this function as x approaches 2 is, well, no longer b because I have an actual number. It is what? Well, what's the intended height of the function? Remember, the intended height of the function, we're just following the graph. And we really do have to say it has to have the same intended height from the left side as it does when we follow it up from the right side. The intended height of this function is the same from the left and the right, even though there's a big old hole in it. It is 4. However, f of 2 is not 4. It's also not undefined. Look down here, it is 1, okay? So we have removable discontinuity here. So this is also another example of where the limit does exist, but the function's value doesn't. Or it does, it's just not the same as the limit. Okay, one more. Question I get, when doesn't the limit exist? Okay, well, the limit doesn't exist when the function is confused. When from the left side and the right side, they don't agree. Okay, so let's get some 2 and we'll say 4 here. Okay, so let's go here and draw a circle. Okay, and then let's make it this a little thicker here and draw this, and maybe it goes off that way. And there's no reason for one to be thicker than the other. Okay. So there's my function. It's the ugliest thing you might have ever seen, but it's still a function and it works. Okay, so let's look at our limits here. As we approach this from the left, okay, as we come this function from the left, from values from negative infinity, what is the limit? The intended height of the function appears to be over here at 1. Great. As we approach it from the right, what happens? Well, the intended height of the function is 4. So we have two different limits, and we write it like this. The limit as x approaches 3 from the left, so with the little negative sign in the exponent spot, we say, well, as we came up from the left, the limit was 1. As we came from the right, limit as x approaches 3 from the right side, it was 4. Since the limits do not agree, the limit does not exist. That is when it doesn't exist. When they are confused, when the left side and right side do not agree and do not come to the same spot. All right, so let's go back to the original question that started this all. And this, by the way, guys, is exactly what you can send. When you subscribe and send me your problem, you just take a picture and email it just like this. It doesn't have to look great. I can see this perfectly. Okay, so it says, for all values greater than 2, the limit is 1. All right, so let's go ahead and put something that looks like that. Coming from the right side, the limit is 1, but it's just greater than 2. So let's not fill that in. Let's put a little circle, but let's keep it open. So here's my 1, okay, and here's my 2 down here, and I'm going to draw a circle. And I'm just going to draw a little graph that comes from it. Okay, so as I came from values greater than 2, right, as I follow this graph up from infinity, it lands at 1. The intended height is 1. All right, well, as I come from the other side, as I come from the left side, my intended height is not 1. It is 2. So let's see if we can change colors here maybe. Okay, so it's 2. So coming from the left, and now it says when it's less than or equal to 2. So since 2 is a solution here, or 2 is included in this interval, I'm going to go ahead and fill it in. So where's my 2? It's right here, and there we go. That's a nice filled in circle, and it's when I come from the other direction, so I'm just going to draw my graph. You can make it look any old way you want. Okay, so that's fine. So coming from the left, values less than or equal to 2, the limit, the intended height of the function is 2. Coming from the right, let's see if I could trace this here. Coming from the right, the intended height is 1. That's my 1. Coming from the left, my intended height, coming all the way down from the left as I reach 2, my intended height is 2, and there it is at 2. Okay, so it's a little bit messy because we've added some stuff there. We could have made this so much easier though. We really could have just said, let's say this. Let's say we wanted to say, all right, coming from the right, x equals 2, right? It's 2. The height is 2. Let's make this a little thicker so you can see it. We could have said, okay, well, there's my intended height when I come from the left. Okay, I come from the left, my intended height is 2. There's my function. When I come from the right, my intended height is 1, but value is greater than 2, or 2 is not included, so there I go. We could have simplified it way down, okay? Still works. All you need to know, closed circle, approaching 2 from the left at y equals 2, open circle, approaching 2 from the right at y equals 1. Okay, that was a lot to say in one little short video. If you have questions, if I have confused you, if I need to redo this, put questions and comments in the comments section. And remember, I only did this problem because one of my subscribers emailed it to me. So if you're not yet a subscriber, go ahead and hit the subscribe button. That way when you're doing homework and you see a lousy problem and you don't want to do it, but you want to know how to do it, you can send it to me too and I'll do that one. Thanks for watching.